It takes a bit of work to get a cost function, but once you have it, solving the firm's problem becomes really simple, even simpler than it was before. So in the example, we found a cost function that looked like this. I think it was 2 times WR to the 1/2 power times Q squared. So this can be a cost function. It's totally allowed. And what if we now have to solve our profit problem? So our profit is price times quantity minus our cost function. And we know that our costs are WR to the 1/2 times Q squared. So this problem has now collapsed into find the value of Q that maximizes profit, and we know how to get that Q at the most cost-effective way. All right, so there's only one choice variable, Q. We take the derivative, and we get P minus, there's a 2 here, or there's a, so we multiply that, 4 WR to the 1/2 Q, because we subtract 1 from it. We still set this equal to 0, and we've got a really nice function here, okay? Let's solve this. We get P equals 4 times WR to the 1/2 times Q. Let's divide both sides by 4 WR to the 1/2. That gets canceled out, and we end up with Q equal to P divided by 4 times WR to the 1/2. This is called an individual supply curve. Okay, and I'm now going to start changing the notation. I've been kind of loose up till here, but from here on out, we're going to have individual supply curves be denoted by a lowercase q, and the supply of an entire market denoted by an uppercase Q. Okay, and we'll see why in the next video. Okay, so why is this an individual supply curve? Because it tells us if the firm is maximizing profit, how much quantity it should supply as the price changes. Notice it also tells us how the quantity should change as wage rates change or are. And this is a good reminder that, you know, the factors that drive Q, we think of typically the price being the big one, like we focus on that in supply and demand diagrams, but going through the underlying mechanics of where that supply curve comes from reminds us that it also depends on the cost of inputs. And you can see here that in this case, if the cost of inputs goes up, we're going to supply less. Okay? In this case, the cost of inputs are W and R. But we can't quite see it here, but it also depends on the structure of the production function. So this all is derived from the assumption that the firm makes goods according to this formula, K to the 1/4, L to the 1/4. If we had a different production function, we would have, I'm going to put the end of my parentheses there, we would have a different supply curve, okay? And so all of these things, if they change, can change supply. And that's sort of important to know. We focus on price, but things that will also shift that curve around include the cost of inputs and the structure of the production function, okay? Now, let's do this one more time, but kind of generically, okay? So suppose we just have P equal to PQ minus the cost function. And now I have just C as a function of Q. It's a generic cost function. If I take the derivative, and I'm sorry, this should be a lowercase q. That's my new notation. I get P minus the derivative of this cost function is equal to 0. The derivative here of a cost function is called marginal cost. And what this is saying is that to maximize profit, a firm sets under the assumptions we've set out at the beginning where they can't control price, they just take it, it's exogenously given. In that situation, a firm maximizes profit by setting price equal to marginal cost. Okay? So I'm going to write that because equals marginal cost, and this is under perfect competition assumptions, which we are in for this whole unit. And in the next unit, we'll say, hold on, are those assumptions good? And we'll say probably not. And we'll talk about how that changes things. But let's start here. It's useful. All right, so price equals marginal cost. And the logic here is very similar to the logic for why a firm sets wages equal to the price times the marginal product of labor, and so on, right? Remember with that, it was the idea that if they weren't equal, then a firm could make more money by hiring more workers or hiring fewer workers, okay? It's the same idea here. If the price is greater than the marginal cost, that means that if you make one more unit, the marginal cost tells you how much it's going to cost to make one more unit, because the derivative of a cost function tells us how total cost changes when you increase Q. So if price is larger than marginal cost, increasing the quantity, making one more unit, costs less than the price you sell it for, okay? And that means that a firm is going to make money by making an additional unit. And if it can make more money by changing its behavior, then its previous behavior was not maximizing profit. Similarly, if the price was ever less than marginal cost, that would say that the last unit it made cost more to make than generated in revenue. In that case, the firm should not produce it, save on the cost of production, sell one less unit, and it will still be a little bit better off. Okay? So this is the intuition. And the key idea is we assume price equals marginal cost, and from that, we generate an individual supply curve by solving for Q. So we have something like P equals C prime of Q, and we need to solve this for Q equal to some supply function of price. And that is how you get an individual's supply curve.